Okay, so it says here f times g of x and g of x. So they're giving us two graphs in here. We actually don't have the function for each one, although we could figure out what the functions are. It says here, sketch the graph of f of x. Now, first of all, what does this mean? F times g. So this means it's f of x times g of x. So this is another way of saying f times g of x. Okay, that means that. And then this is just a g of x. Sketch the graph of f of x. So how can we get an f of x for this one? The way you can get f of x is if you go f times f of x times g of x divided by the g of x. You can't see that, sorry. So you start off with this and you divide it by this. You're gonna cancel those out. Now, f of x is the y value of the function f. So here's what we're gonna do. Now, looking at this one here, f of x times g of x, the domain here, so this is the domain is from 0 to infinity, right? So from 0 to infinity, it's defined from 0 to infinity. What about this one? This is going to be defined from negative infinity to positive infinity. Now, this one only starts from 0 to infinity. This starts from negative infinity to positive infinity. So really, if we are to combine them, we won't have any responses or any result for this one, right? From negative infinity to 0. So here's what we're gonna do. So this is a while back. This is our f of x, f of x times g of x. And then the g of x. What we're gonna do is we're gonna divide this by this to get the f of x. So we said that the domain is from 0 to infinity. So we're just gonna pick values 0, 1, 2, 3, 4. Okay, that should be good. You can do more if you want. So from here, if x is 0, I'm gonna switch back and forth in here. If x is 0, what's the value of this? So if x is 0 here, it's going to be 3. If x is 1, what is the value of f times g of x? If x is 1, the value of f times g of x is 4. If x is 2, what is the value of f times g of x? 3. Okay. If x is 3, what is the value of f times g of x? 0. If x is 4, 1, 2, 3, 4, that would be a probably negative 1, 2, 3, 4. Okay, it's too far. Okay. So 1, 2, 3, 4. 1, 2, 3. Yeah, 4 point something. It's a little bit. Okay. 4 point something. Okay, we'll leave it to that for now. So now let's go to this one. We're gonna look at the function g of x. G of x. This one. Honest, you want one? Did I give you one? Okay. G of x. Well, if x is 0, what's the value of g of x? 1. If x is 0, it's 1, right? Okay, good. If x is 1, what is the value of g of 1? 1, and that's 2. So 2. If x is 2, what is the value of g of 2? 3, right? Okay. So we'll start from there. Now, what did it say? I gotta go f of x times g of x divided by g of x. That's gonna give us just the f of x. So 3 divided by 1 is 3. 4 divided by 2 is 2. 3 divided by 3 is 1. So, let's graph it. What's the graph of f of x? F of x would be 0, 3. 0, 3. The other one, 1, 2. So 1, 2. And then 0, 3, 1, 2, 2, 1. And then you'll probably see from here. We'll go this way. So that's just going to keep going to the negatives. Okay. Now, do I go this way? No, we can't. We can't extend it to the other side, to the second quadrant, because remember, our domain here is from 0 to infinity, and this is from negative infinity to infinity, right? It's not, so the only place that it's defined is from 0 to infinity. Okay, is that good? Is there anything else that you want us to take a look at? Yeah, or booklet 1 or 2, doesn't matter. 37. Determine an equation of a radical function with a domain of x greater than 5 equal to 5 and a range of y greater than or equal to negative 2. So let's start off with what we already know, radical function. Radical function, that's y equals to root of x, right? So we want the domain to be greater than 5. Okay, let's see the graph of that. Just to show the graph, see what that looks like. So that's going to be like this, right? That's a square root of x. Now you want the domain to be greater than or equal to 5. So that means we have to move this graph this way 5 units to the right. So 1, 2, 3, 4, 5. And it says here, the graph has to have a range of y greater than or equal to negative 2. So if we start at negative 2 here, and anything above, there's 2. So it's basically a transformation question. So transforming this to get the domain and range of these values. So what would that be? It would be square root of x minus 5. Okay. and then shifted down 2, so minus 2.
I don't have to bracket.
Yeah, you could bracket it. Yeah, or you don't have to, because that radical, as long as we don't go all the way down to the negative 2. What if it's not equal? What if it's just strictly less than 5, like that? Then we would have to say where x cannot equal to 5, and you would have an open thing there. Yeah. But I think that's, yeah. So I'm thinking 2 marks would be the shifting here and then 1 there. Horizontal shifting and vertical shifting. Okay? Good? Yeah. Any other ones? Okay, you're good? Okay, I hope you would try them, and there's some graphing, inverse. Okay, you remember how to do inverses? Graphing. Oh, 4 marks. That's a lot of, yeah, that's pretty good. Let's do this one. Okay, let's try this one. So this one here is a specific function. The specific function here is square root of x. Yes, that's our most basic function. Now, what happened here? How did they get from here to 1/2 root of negative x plus 1? What kind of transformation? What kind of transformation? What does a 1/2 represent? Vertical compression. What else? Are you talking about this one? Okay, reflection over the y-axis. Yeah, reflection over y-axis. And what else? Oh, this one is outside the radical, so that's up 1. Yeah, so up 1. Okay, we have to make sure that if it's inside the radical, then that's part of the brackets, but this is outside, so that means it's up 1. So vertical compression, that's gonna give us, which value is this? A, B, or H or K? This is gonna be A, right? A is 1/2. What about this one? Reflection over the y-axis. -1 for B. B is -1. Okay. What about this one?
K.
This is the K. K, which is the vertical, or the D, right? So 1.
Can we call it a D too?
Yeah, we can call it a D. Yeah, to make it kind of go with A, B, C, and D. Yeah. Okay. So what we're gonna do is, first of all, for the function y equals to root of x, we have our x and y values. Okay, so what are x and y values? 0, 0, 1, 1, 4, 2. Yeah, we're going to use the nice numbers. Remember, this is a piece where you're not allowed to use a calculator, right? So, in our transformation, it says here, A is 1/2, so I'm going to go 1/2 for A. Hold on. 1/2 for A times y plus 1. Okay, that's for the y. And then for x, it's going to be x over negative 1 because it's x over b, and that's it. Just so to remind ourselves, it's going to be x over b plus h or c, okay, a times y plus k or d if you wanted to do a, b, c, and d. So from here, it's going to be 0 divided by negative 1 is 0. We could do negative 1, negative 4. And then here, a half of 0 is 0 plus 1 is 1. A half of 1 is a half plus 1, 1.5. And a half of 2, which is 1 plus 1 is 2. So it's going to be 0, 1, negative 1, negative 1, 1.5, and then negative 4, 2. 1, 2, 3, 4, 1. And it's going to be this way. I have to make sure that I have an arrow over there, so that indicates that it's going to continue on to this direction.
And it's allowed to be negative x since the x values are negative themselves.
Yes, x would be it's going to be it has to be a negative, because a negative times a negative will give you a positive value, and we're able to take a square root of that. Yes, that's right.
Okay, so the negative 1 comes from that negative symbol as well, right? So it's x minus.
Yeah, so this is really saying it's going to be negative 1 times x. Yeah. Like that. So whatever the negative value for x is, it's going to be times by negative 1, which makes it a positive. Okay? Is that good?
Can you do the next question?
Inverses. Okay. Now this one is an inverse, and what do we do for the inverse? Yes. So switching the x and the y, and then we're gonna resolve for the y. So this is gonna be y equals to 3x over 4 plus 9. That's what that is. We're going to switch the x and the y's. Okay, let's do that. X is equals to 3y over 4 plus 9. And then from here, we're just going to slowly get rid of the 3, the 4, and the 9 to have the y alone. So how do we do that? Bring the 9 over to the other side. It's going to be x minus 9 equals to 3 times y over 4. And then what are we going to do next? We're going to cross multiply. Okay, I got to make sure that I'm multiplying everything in here. So I need to have a bracket. So 4 times x minus 9 equals to 3y. And then finally divided by 3. Divided by 3. So y is equal to 4. You can leave it as 4x minus 9 over 3. Or you can go 4x minus 36 over 3.
I like how you can leave it like that,
Yeah.
in case you don't trust yourself there.
Yeah. Or you can go y is equals to 4/3 x minus 12. Yeah. Okay, it's all good. Anything in here?
When you're just describing that in words.
Oh, 45. Yeah, we kind of talked about this yesterday. Well, just us two. So it says here, given a graph. Well, when I looked at this, like, given the graph, like, what graph? Because when they say given a graph, I'm expecting a graph here. It kind of threw me off here for a second. So it says here, given the graph of y equals to f of x, describe how to sketch the graph of y equals to absolute value of f of x. The absolute value takes the negative value, negative y, and turn it to a positive. So in this case, it says here describe. So how do we describe it on how to sketch? So to describe that, let me show you something first. Start with something. So we said that, let's say this is y equals to f of x. And we want to do the absolute value of that. What are we going to do? We take this, the one and the negative, and then what do we do?
Flip it up.
Reflect it up this way. Okay? We reflect over, okay, the portion of the graph below the x-axis will reflect over the x-axis. So y values are positive. So we're not really just reflecting over the x-axis, we're only reflecting the one below the x-axis over. So if this is so this is now gone, and then this is, if the graph looks like this, okay, how do we do it? The portion, this one below here, below the x-axis will get reflected over the x-axis so that the y values are positive. Okay, is that good? Anything else in here? Did you try your favorite?
My favorite? What's the favorite?
I don't know, log maybe?
Log. Log's fun.
Oh, yeah, this one here, explain why only one of the following equations could be solved algebraically without the use of logarithm.
So use the exponent.
So which one can we not use logarithm here? Could be solved without.
So use the second.
Okay, which one can be solved without?
Second.
Second, yeah, second. So this one could be solved without. Why?
Change
Because it says here explain why. So we're gonna say this one, the second one, why? We have to explain why. Okay, the one mark is not the choosing, the one mark is the explaining why. And why is that?
Oh god. I just solved it. Do you have to use words?
Yeah, because it says explain.
But isn't this explaining?
Is that
Is that not explaining?
oh, well, what? Okay, write it in words. What did you do to solve it without it?
Change the basis.
Yeah, it's like, yeah, stop interrupting me. So we can change to same base, right? This one, what would be the same base? What did you use?
2.
2. Yeah, we could use a 2. Okay? That's one mark. Just explain why.
I just did it.
And you just did it. Okay. logarithm. Sketch the graph. Okay, what's the logarithm graph? Exponential graph is gonna be 0, 1 and 1 base. For logarithm, it's gonna be 1, 0 base 1. It's inverse of each other, right? Inverse. And that's the thing about the inverse. I think we did that. We were able to figure out the inverse before, inverse equation. But inverse is switching the x and y value. It's a reflection over the y equals to x equation. So here, this one would be log of base 3x plus 4. Okay. So this is going to be 1, 0 base 1. So base is 3. So the graph kind of goes like this, right? You got your asymptote there. Now what happened in here? Shift 4 where? Left 4. So everything is 4 left. 1, 2, 3, 4. 1, 2, 3, 4. Where's your asymptote? Yeah, we can't just do this. We have to make sure our asymptotes also tag along. So it's going to be at negative 4. Okay. So draw your asymptote and make sure there's a arrow. And then there's your graph like this. Kind of go like that. And you can erase that piece. Okay. So if you do the other graph, make sure you just erase that so it doesn't look like you have two graphs going on. It's just, or if you have two graphs going on at the same time, you can say, hey, I'm saying this is my y log base 3 of x plus 4. And then this one would be my y equals to log of x base 3. Okay? Or just erase it. Okay, how's it? So far so good? Okay. Ooh, your favorite. Want to give that a try, or have you tried that one?
Same base.
Huh?
They all have the same base.
They have the same base 10. Yeah, they have the same base 10.
Do you want me to book?
Yeah. We're gonna do a new book.
I got 3 books on the go right now. I just look like a crazy person.
Did we do this one? Oh, we did it already. Oh, okay.
Did we?
Did we? Oh, okay. We did. Okay, I'm not sure. I don't even remember.
I don't know if we did it together. I can't remember.
I can't remember.
That one's still pretty fresh though.
Yeah. Okay. Good. So yeah, what I'm gonna do is I'm gonna give you the newest book. Booklet 1. And this is the most newest. It's just like 5 months ago, right? So you can work alone, you can work with somebody.